The energy from the sun is called solar energy, or solar radiation. Heat and light may be the most obvious forms of radiant energy, but there are others present, which are invisible to our senses. The energy from the sun comes to Earth in the form of electromagnetic waves called radiation. A small part of the sun's energy that comes in contact with the Earth's atmosphere is reflected back into space when it hits dust and water particles. Some of the radiant energy is scattered throughout the atmosphere. Harmful gamma rays, X-rays, and some of the ultraviolet rays are not allowed through the atmosphere. We are protected from these harmful rays by the filtering effect of the atmosphere. About 10 to 30 miles above the Earth is the naturally occurring ozone layer, which absorbs much of the sun's ultraviolet radiation. It shields us from these harmful rays. Part of the sun's energy reaches the Earth's surface where it is absorbed or reflected. How much energy is absorbed depends on the type of surface the energy strikes, the angle of the sun, and the intensity of the sunlight. Snow and ice reflect radiant energy, while soil and rocks tend to absorb energy. Think of how hot an asphalt parking lot can get on a warm, clear, sunny day. Or have you ever touched a car that has sat in the hot summer sunlight all day? Dark objects, like the asphalt, and dark-colored objects, like the car, can absorb a lot of energy. Heat moves from one place to another by one of these three methods. Radiation is heat transfer by electromagnetic waves. When standing in front of a fireplace, the side facing the fire is warmed, while the other side of a person's body seems cool. Conduction transfers heat by contact. Transfer is always from warmer to colder regions. A spoon becomes hot to the touch while sitting in boiling soup because of conduction. The third method of heat transfer is convection. Convection is the transfer of heat through a fluid caused by motions which mix and transport energy. Look at the noodles moving about in this pot of heated water. Together, all three forms of heat transfer work to circulate energy in the atmosphere. Heat energy from the sun in the form of radiant energy travels through space by radiation. The radiant energy warms the surface of the Earth. Air near the Earth is heated by conduction. The heated air expands and becomes less dense than the surrounding cooler air. This expanded warm air is buoyed upward and rises. Cooler, heavier air flows in to replace the rising air. Then this cooler air becomes heated, and the whole cycle starts again. The movement from rising air to spreading out to falling cool air creates wind. This circulates energy throughout the atmosphere. Temperatures around the Earth vary greatly. Temperatures at the North and South poles are much lower than the temperatures at the equator. This occurs because of the Earth's tilt, the angle of the Earth to the sun. The Earth spins on an imaginary axis. The Earth is tilted on its axis at an angle of 23.5 degrees. This tilt is responsible for our seasons and the temperature differences. When the northern hemisphere is tilted away from the sun, then the southern hemisphere is tilted towards the sun. So the northern hemisphere receives less radiant energy and experiences winter, while the southern hemisphere has summer. The number of hours of sunlight help to determine how much radiant energy is absorbed by the Earth's surface. When tilted away from the sun, there are fewer hours of sunlight. The other thing that influences the amount of energy is the angle of the sun's rays. We can illustrate this idea with a flashlight and some graph paper. When the light strikes the paper at a 90-degree angle, the light is concentrated. When the flashlight is at an angle, a larger area is covered by the light. The same amount of light is then spread out over a larger area, so less of it strikes any given point. The same thing happens with the rays of sunlight. At the equator, the rays are more direct than at other locations. Temperatures near the equator are warm throughout the year. So the length of daylight and the angle at which the sun's radiant energy strikes the earth changes from day to day and season to season. The earth is divided into climate zones based on the amount of radiant energy received by regions of the earth. Climate is the average weather conditions of an area, daily and seasonal weather events over an extended period of time. Remember, there are two driving forces that affect weather: the sun and moisture. Let's look at moisture now. Water vapor is an important part of the Earth's atmosphere. Water vapor is the gaseous form of water. To understand how the moisture or water vapor gets into the air, you must understand the water cycle. The amount of water on our planet is a finite amount. Though 3/4 of the surface is covered by water, only 3% of the Earth's water is fresh water. For billions of years, the Earth's water has been recycling through a process called the water cycle. The cycle is powered by energy from the sun. Heat energy causes water in the oceans, lakes, and soil to evaporate. The heat causes molecules to move faster and farther apart. The liquid water may change to a gaseous state, called water vapor, and rise into the atmosphere. Moisture is also added to the atmosphere when plants release water vapor from their leaves in a process called transpiration. As the water vapor rises in the atmosphere and cools, clouds begin to form. If cooling continues, the water vapor may condense into water droplets or ice crystals. As the cooling continues, the water returns to the earth as precipitation. This precipitation is fresh water because when ocean water or tainted water evaporates, only fresh water vapor is released. Other particles, such as salts, are too heavy to evaporate.